Okay, in this video, we're going to go over a problem that involves kinematics, energy and work, and also some friction. So this is just a car coming to a stop. So the problem says a 1,200 kilogram car is driving down a road at a constant velocity of 24 meters per second. Then a deer walks into the road 52 meters ahead. If it takes the driver 0.8 seconds to react, what acceleration is needed to stop right before hitting the deer? And what's the necessary coefficient of kinetic friction on the road in order for this to occur if there's no slipping? Okay, so there's quite a lot here. So let's go ahead and draw a picture and figure out what we know and how to get the acceleration. So here is our car. And here is the deer. So we know that this deer is initially 52 meters away. And this car is initially moving forward at a velocity of 24 meters per second. They also tell us that the mass is 1,200 kilograms. And there's a reaction time of the driver equal to 0.8 seconds. So during that reaction time, the driver has not started to decelerate yet. Okay, and we know that eventually the car comes to a stop. So that means that our final velocity is 0 meters per second. Okay, so the first thing we want to do in this first part of our problem is to figure out how far this car drives during the reaction time. So initially you're 52 meters away, but you're going to advance forward during that 0.8 seconds. And we want to subtract that off of the total distance and figure out what distance he's actually braking over so that we can find the acceleration. So the reaction distance is what we're going to call this, is equal to this initial velocity the car is moving at times the reaction time. And that's going to be 24 meters per second times 0.8 seconds. And that is going to be about 19 meters. All right, so then that means this here is dr. And the remainder is what we're going to call delta x, and this is the distance that the car is braking over or decelerating. Okay, so let's go ahead and subtract 19 from 52 to get delta x. And that's about 33 meters. All right, so now we want to find the acceleration. So we can use the equation v final squared equals v initial squared plus 2 times the acceleration times the distance, which in this case is delta x. All right, so we already know that v final is going to be 0. So this term is 0, and we can just subtract 2a delta x to the other side. That's equal to v initial squared. And just divide by negative 2 delta x to get the acceleration is equal to negative v initial squared times 2 delta x. So that's going to be 24 meters per second squared. This is negative. Make sure not to square the negative sign, as it was not a part of that v initial. And divide by 2 times 33 meters. And this is going to give us an acceleration of negative 8.2 meters per second squared. And so this is actually a pretty high acceleration in order to stop. Okay, so now we want to find the coefficient of kinetic friction on the road in order for this car to be able to stop. So here, this is part 2, we're going to look at work and energy. The work is going to be equal to the change in kinetic energy. And of course, that's just 1/2 times the mass times v final squared minus 1/2 times the mass times v initial squared. And this work is, in this case, equal to the, so this is the work done by friction, so that's going to be equal to the force of friction times the distance that the car is braking. Let's go ahead and simplify this a little bit. All right, so we know that v final is 0, so again, this term is 0. So that's just going to leave us with negative 1/2 mv initial squared equal to the force of friction times this distance. So the force of friction is going to be in the negative direction, right? So it's going against the motion in order to slow it down. So this is our force of friction up here. And that's equal to negative mu mg. And then we're multiplying the distance that this is happening over, and that's delta x. We do have the mass on both sides, so these are just going to cancel out. We don't have to worry about that. And both sides are negative, so that's just going to end up being positive. So now we can just solve for mu. It's the coefficient of kinetic friction. That's just going to be v initial squared divided by 2 times g times delta x. So let's just go ahead and plug in these values. 2 times g, which is, of course, 9.8 meters per second squared, times the 33 meters. And that gives us a coefficient of friction of 0.84. So it has to have a pretty high coefficient of kinetic friction in order to be able to stop and not hit the steer. So that's how you do one of these problems where they're kind of combining kinematics and work and energy problems. So as you get further into your physics class, you're going to have to start combining all of these different concepts. So hopefully that was helpful, and let me know if there's anything else you guys would like to see.